everybody, and once again welcome to Pankaj Sir's Echelon tutorials. And in this today's session we are going to deal with ICSC 7th grade. Okay, so you can see on the screen today's session is dedicated for ICSC 7th grade. Okay, and today I am going to start with the subject mathematics. Okay, and in that mathematics subject, okay, I'm going to start with something called a topic called products. Okay, the topic name is products. Okay, or also sometimes in some book it is referred to as expansion, so I'll write products and expansion, right? So this is the name of the topic that we are going to start today. So without any delay, let us get started to this mathematics 7th grade ICSE products and expansion. Fine. Now this is a very cute, short, but a very important topic. Many students, they are not very familiar with this expansion, with this product. Okay, and once you know what are the rules that works behind it, okay, things will automatically fit into your brain and you'll start working. Okay, so today's session we can start with what are products and what are expansion. Now when I say what are products and what are expansion, let me start first with an example of the meaning of a product. Now suppose you have a number 5 and you have another number 3. When you multiply them, okay, you say that you are finding the product of them. Okay, so multiplying 5 by 3 is as good as finding the product of 5 and 3. So the product of 5 and 3 happens to be 15. So this 15 is known as the product of 5 and 3. Okay, this is nothing but the product of numbers. But suppose in algebra you have an expression like say x plus a, and you have another expression say x plus b. Okay, now these are in place of numbers. I have put now algebraic expressions. So this is x plus a and this is x plus b. These are two expressions, and can you see I have put them in bracket so that you should be able to identify that these are two different expressions. Okay, so brackets are very important. Brackets are going to play very important role in this particular topic. Okay, and in between the brackets I have not put either plus or minus. Okay, neither I have put multiplication or division sign. Okay, but when I have not put anything, that means that there is a multiplication sign. Okay, so x plus a into x plus b, okay, is equal to whatever answer you will get, that will be the product. Okay, so this product, if you want to find out of two algebraic expression, okay, how we are going to do it. So let me tell you, these two algebraic expressions are known as binomials. Okay, because there are two terms in this. X is the first term, a is the second term in this. Here x is the first term, b is the second term. Okay, so this is known as the first term, this is known as the second term of this particular binomial expression, and this x is the first term and this b is the second term of the second binomial expression. Okay, so whenever you want to find out the product of two binomials, okay, what you have to do is you have to take the first term. Now these are the rules, okay, which you have to follow. So you have to take the first term, so I'll write here first term. Okay, first term of the first binomial. Okay, so first term of the first binomial, or let me write it directly. Okay, I don't think you will find it difficult. So let us take this first term of the I'm so sorry, uh, this is x plus a, right? Fine. So take the first term. So this is the first term of the first expression, first binomial expression, that you take first term and you multiply with the entire second term. So the entire second binomial expression. Okay, multiply the first term of the first binomial expression with the entire second binomial expression, that is x plus b. Okay, then what you do, along with this sign of the second term, you take the second term along with the sign. Now this second term is a, okay, but the sign before a is plus, so you have to take that plus a, and then that plus a also you multiply with the second expression, so it will be x plus b. Okay, that is the first step that you have to do. Okay, then what you have to do is you have to open the bracket. What is the meaning of opening the bracket? Whatever is outside, that you have to multiply by the things that are inside the bracket. Okay, now this is known as distributive property. Okay, so this you will have to multiply with this. X into x will be x square, then there's a plus sign over here, so put a plus sign, and then x into b will be xb. Okay, then coming to this, plus a into x will be plus ax again, and plus into plus is plus, and a into b is ab, so it will be ab. So your answer will be x square plus, now here you can see it is xb plus ax. Okay, so in these two terms you can see that x is common, so I'll take x common out and I'll write b plus a. Okay, plus a ab. So this is the expansion. Now here we have to end the expansion because further we cannot do anything about this. Okay, so we are getting now three terms, 1, 2 and 3. Okay, so we are getting the expansion of this product, right? This is the way you have to do the expansion. Okay, I'll give you one more example. Suppose you have a x plus a, this is the first binomial, and you want to multiply it by a second binomial which is x minus b. Okay, so same way you have to take the first term of the first binomial expression, that is x, and you have to multiply with the entire second expression, that is x minus b. Okay, then along with the sign you have to take the second term, that is plus a, and you have to multiply that again with the second expression, that is x minus b. Okay, first step being done. Coming to the second step, opening the bracket. Opening the bracket means multiply this by this and multiply this by this. Okay, so x into x will be x square, and there's a plus over here. Okay, so plus into minus will be minus, x into b will be bx or xb. Then coming to this, now see I am not putting brackets, now I am actually removing the brackets. I am opening the brackets. Opening the brackets is as good as removing the brackets. Okay, now plus into plus, here also there is a plus. See, if there is no sign mentioned before any variable, you have to assume it to be as plus. Okay, so this is plus a and this is plus x, right? So plus into plus is plus and it will be ax. A into x is ax. Okay, then this into this, so plus into minus is minus and a into b is ab. See what I am doing, be careful over here. I am multiplying the sign also as well as I am multiplying the variables also. Okay, so both you have to take care of. Okay, don't do in a hurry, and don't just concentrate on multiplying the variables without paying attention to the sign. Okay, signs are very important. Okay, the rule is plus into plus is a plus, minus into minus is a plus, plus into minus is a minus, and minus into plus is a minus. Okay, this rule you must be knowing. In integers we have already studied this rule. Okay, and in directed numbers, okay, we know these rules. Okay, so applying this rule, now if you can simplify you can. Okay, you have to simplify. Now here you are getting four terms, but can you see this center two terms? Okay, this x square I am writing as it is because I cannot do anything about it. Okay, now this is a minus bx plus ax. Now in these two terms, I can see that x is common. Okay, so I'll take plus x common. Okay, then I'll put a bracket. Now from this term, if I take plus x outside, what will remain? Minus b. So I'll write a minus b over here. And from this term, if I take x plus x outside, what will remain? Plus a will remain. So minus b plus a, and then minus ab. Okay, so this happens to be x square plus x into minus b plus a minus ab. Okay, now let me tell you one more thing. This minus b plus a can any day be written as a minus b. So in mathematics, minus b plus a is same as a minus b. This you have to put it in your mind. Okay, properly. Minus b plus a is same as a minus b. So you can just write this as x square plus x into a minus b minus ab. So this happens to be a expansion of the uh, second example. Okay, so it is x square plus x and a minus b minus ab. Okay, is that clear? Fine. Okay, now coming to the third one. Third one is x minus a times x plus b. Okay, now let us see how we can do this expansion. Okay, now because I have explained you two example in detail, now this I am going to be a bit quicker. Okay, so first term of the first expression I am taking, I am multiplying that with the second expression. Then I am taking the second term of the first expression along with the sign, that is minus a, and I am multiplying with the second term x plus b. Now I am going to remove the bracket, so x into x will be x square. This is plus, so plus into plus is plus, and b into x will be bx. Okay, then coming here, this is minus into plus is minus. Here there is a plus. Okay, so plus into minus is minus, and a into x will be ax. Okay, then coming to this, plus into minus is minus, and a into b is ab. Now, last step. These two terms you can see in the center. In these two terms, x is common. So, I'll take this x square as it is. From these two terms, I'll take plus x as common. When I take plus x as common, from this first term, when plus x is gone, you are left with only b. Okay, plus b. Then when plus x is out from the second term, okay, plus x is out. So, you are left with a minus a. So, b minus a. Then close the bracket and then minus ab. Okay. Now remember here b minus a cannot be written as a minus b. Okay, don't make this mistake. Okay, here I told you it is minus b plus a can be written as a minus b. B minus a cannot be written as a minus b. So you'll have to keep it as it is. Okay, so that was the third one. Okay, so that was third. Now let me do one more expansion. Suppose you have x minus a and you have a x minus b. Okay, these are two binomial expressions. You want to find the product of these two. So take the first term of the first, that is x, multiply by the entire second term, that is x minus b. Then take minus a, I have taken minus a, multiply by the same x minus b, so x minus b. Now coming to next step, x into x, x square. Now plus into minus minus, x into b is bx. Then coming to here, plus into minus minus, a into x is ax. Then minus into minus plus, a into b is ab. Okay, and last but not the least, x square. Now from here I will take minus x as common. Okay, so when minus x is taken from this first term, okay, minus x, so b will be left over here, and from this second term when minus x is taken away, you'll be left with a plus a. Okay, and then plus ab. So the answer for this can be written as x square minus, now this x can be written on this side as well. Okay, so now and a plus b can be written as b plus a any day, no issue. Okay, so either you write b plus a or you write a plus b, one and the same thing, and this x I'm writing on this side, no problem. Okay, plus ab. So that's the answer for the fourth one. So x minus a into x minus b happens to be x square minus a plus b into x plus a ab. Is that clear? So this is how expansion has to be carried out. Okay, the product has to be carried out. Okay, now I'm going to talk about some identities. Now what is identity? Identity is something that works for all the values of the variables. Okay, so this fourth I have explained you the expansion. Now the next one is, suppose you have this kind of an expression. Okay, a plus b the whole square. Now this is also a product of two terms. Okay, I'll give you an example. Suppose somebody is telling you find out 5 square. Now what is the meaning of this? The meaning of 5 square is 5 into 5. Okay, so ultimately you have to find out the product of 5 and 5, which is 25, isn't it? So whenever a term is given in this form, that is square form, the meaning of that is a plus b. A plus b whole square means a plus b multiplied by a plus b again. Okay, this is the meaning of it, right? Now when you have the two expressions which are same, okay, identical, and if you want to find out the product, what you will have to do? Same rule you will have to follow, okay. So take the first term, that is a, multiply it by a plus b, then take plus b and multiply by the entire a plus b again. Then remove the bracket, a into a will be a square, plus a into b will be ab, then plus b into plus a will be plus again ab, and plus into plus is plus and b into b is b square. Got it? Now this final answer can be written as a square. Now this is AB and this is AB. These are known as like terms. Okay, AB and AB are known as like terms. AB and AB both are like terms, and these are the coefficients of the like term. Okay, this 1 and 1. See, there is nothing written in front of AB, means you have to assume it to be 1. Okay, so 1AB plus 1AB will be 2AB. Okay, so this can be written as AB plus AB as 2AB. Okay, now see, remember this addition of this terms, is possible only if the terms are like. If the terms are not like, you cannot add them. Like for instance, AB and a square b, these two are not like terms. Okay, these are not like terms, these are unlike terms. So you cannot add this and say that this is equal to 1ab plus 1a square b is equal to 2a square b or something like that, 2ab. No, all this will be rubbish. Okay, so only thing, if the terms are like, you can go ahead with the addition and subtraction. Okay, if the terms are not like, you cannot do anything, you have to leave it as it is. Because here the two terms AB and AB are like terms, I added up them to make it 2AB, and this is plus b square. So this is what you get as the product. Okay, a plus b the whole square will be a plus b into a plus b, and the final product will be this. Now see, these are known as expansion because when you find out the product, the number of terms, becomes greater. Okay, now here you can see that there are three terms now. This is one term, this is second term, and this is the third term. Okay, so first there were only two terms, a plus b and a plus b. These two terms were multiplied, okay, to give you three terms, and these three terms are the sum. Okay, the three terms are sum. Okay, first term plus second term plus third term. Okay, so the number of terms is increasing. Okay, that is why it is also known as expansion. Okay, so a plus b the whole square will be a square plus 2ab plus b square. Similarly, a minus b the whole square will be a minus b times a minus b. Okay, that will be equal to a times this a minus b, then I'll take minus b, and again I'll multiply with the same bracket a minus b. The next step will be removing the bracket. So a into a will be a square, plus a into minus b will be minus ab, then minus b into plus a will be minus again ab, and minus into minus is plus, and b into b is b square. So I'm getting a square, I'll keep it as it is, minus ab and minus ab. Now minus ab and minus AB. Now these are two like terms. AB and AB are like terms. Okay, and the coefficients before them are minus 1 and minus 1, isn't it? So minus 1 makes minus 2. So this can be written as minus 2AB. Okay, and then you are left with this b square. So add that plus b square. So this is the answer for a minus b the whole square. Is that clear? And last one is something which can be written as a plus b times a minus b. Now these are two binomial expression, identical, only there is a difference in the sign between them. Okay, this is a plus b, this is a minus b. Okay, if this is the these are the two terms, and if you want to multiply them out, you can write down again a. See, I am using the same rule for all the expansions. Okay, a times a minus b, then plus b times again that same a minus b. Okay, now opening the bracket, this will be a square, this will be minus ab, this will again be okay, here I should take plus b. Okay, here again it will be plus ab, and this will be plus into minus minus, and b into b will be b square. Now can you see here the middle two terms are AB and AB with a plus sign and a minus sign. Now these are two like terms. Okay, AB and AB are like terms, but the sign are opposite. So 2 plus 2 and minus 2, you know, it works out to 0. Okay, minus 3 plus 3 works out to 0. So if two numbers are same, identical, but they have opposite sign, then they will the resultant will be 0. Same way here, AB and AB are two like terms, but the signs are opposite. Okay, so the addition of these two will be 0. So this 2 will work out to 0. So you will be left with a square. This total will be working out to 0. Okay, so I'm not writing 0, or let me write 0 and then minus b square. So let me ignore this 0. It will be a square minus b square. Got it? So this is how we have to perform the expansion. Okay, and this was just a theoretical introduction to this product and expansion, and I have taught you the basic idea of how to add two binomial expressions, okay, and how to find the product. Okay, the basic idea I have explained you, and that basic principle what I have used, that I have explained you. In my further next lecture, I am going to explain you the all these identities, you know, all these identities, these three identities which we have studied, and there will be more identities which will be coming. Okay, so all these identities I'll be making you understand in a different way. Okay, not this method but a different method, right? So all the methods, you know, possible methods, you have to study, you have to learn. Okay, because in future you will be using all these identities in your mathematics throughout your life. Okay, so this particular chapter is a very basic chapter, or a very basic topic. Okay, you should know how to multiply the binomial expansion, binomial expressions. Okay, and further, you know, in higher classes you will get still complicated expression. You will get not only binomial, you will get a trinomial expression, you will get not only linear expressions, you will get higher order expressions also. So all that is going to come, but for the time being, to start with, this is what is known as the product and expansion, and this is the concept, this is the theory aspect of this particular chapter. So now I am going to end this session here and here itself, because theory and the concept has been explained to you people. In the next session I'll be coming up with some problems, okay, that will be solving. Okay, and that will be in solving those problems we are going to use these particular concepts that I have taught you. Okay, so how to use these identities that I have taught you in this particular session, that will be very important in the coming sessions. So that's all for today. If you happen to like my video, please subscribe my channel and press the bell button as well. Okay, so thank you very much, and take care all of you. Bye.